Welcome to today's video on section 3.3, which discusses properties of logarithms. Remember that logarithms are exponents. So when we talk about properties of logarithms, they're very similar to properties of exponents. For example, if you're talking about exponents and you have two things with the same base, for example, like 5 to the second times 5 to the third, remember you add the exponents and you get 5 to the fifth. Well, for logarithms, it's the same concept. When you multiply two numbers with the same base, so like if you have log base 6 of 3x, you can split it up by adding and make it log base 6 of 3 plus log base 6 of x. So notice it was multiplication here, and you split it up into two separate logarithms with the same base. And it works vice versa. For example, if you had log base 6 of 3 plus log base 6 of x, you could condense it into make it log base 6 of 3x. So it works both ways. So if you're multiplying here, then you can split it up into addition, and if you have addition like this, you could condense it into multiplication. So let's look at a couple examples. So here it says log base 6 of 7 times 11. And it wants us to expand each logarithmic expression, so make it bigger. So to expand it here, if it's multiplication, we just use addition. Remember the base is 6, so we got to go log base 6 of 7 plus log base 6 of 11. The second one here is 100 and x. So we go log 100 plus log x. Now the only thing we have to keep in mind here is that the base of log is 10. And our prior rules have stated that if the base and the number are the same, and remember 100, we can simplify this and make it log base 10 of 10 to the second So notice what happens here is these two cancel out, and remember it just becomes a 2. So it's 2 plus log of x. And we don't need to put the 10s there. I just put the 10s here so you remember that if it's not written, that there is a 10 right there. And that helps us to simplify right here so that it just becomes 2. Because remember, if the base and the number are the same, they cancel each other out, and the answer is just the exponent. So here's our expanded version. It is 2 plus log of x. The quotient rule. Well, remember, when we deal with exponents, when we divide the same base with exponents, we subtract the exponent. So for example, x to the fifth over x squared is the same as x to the 5 minus 2, which is x to the third. Well, with logarithms, it's the same thing. So if I had log base 7 of 5 over x, it would be log base 7 of 5 minus log base 7 of x. And vice versa. If I had this subtraction, I could condense it back into division. So if I want to expand using the quotient rule, notice I have log base 7 of 19 over x. So I'd make it log base 7 of 19 minus log base 7 of x. That would be my final answer. For the second one here, this is an example where we're going to be able to simplify a little more. I can first split it up. It's ln of e to the fifth minus ln of 11. Remember, what is the base? What is the base of ln? Remember the base of ln, it's assumed there's an e there. So remember, this falls into what we were talking about earlier, is that, remember, if the base and the number are the same, they cancel out and you're just left with the exponent 5. So it's actually 5 minus the ln of 11. You do not have to put the e in your final answer. I just wrote it there so that you knew it was there. Because remember, whenever it's ln, it's assumed that e is there. Just like if it's log, it's assumed the 10's there. The power rule. Remember, with the power rule, when you raise a thing with exponents to a power, you multiply the exponent. So for example, x squared raised to the 4th power would be x to the 2 times 4, which would be x to the 8th. So you multiply. Well, the same thing can be said for logarithms. When you're raising a log base of anything to a number that has an exponent, you can multiply. So for example, log base 7 of 3 squared can become 2 times log base 7 of 3. One thing I like to say with the power rule here is it's kind of like this exponent gets rolled off the log. So notice how you're taking this exponent and rolling it to the front, or rolling it off the log. And that is, whenever you're raising the number to a power, you can roll the exponent to the front or roll it off the log. So for example here, the power rule. If we want to expand this logarithm. So notice we take this exponent here, the 9, and we're going to roll it to the front. So it becomes 9 log base 6 of 3, and that is our answer. If I could simplify it more, I would, but here 3 is not a power of 6, so I can't worry about that. If there's a cube root here, remember the first thing you want to do is change this to an exponent. And remember, the cube root of x is the same as x to the 1/3. Then what I will do is I will take this exponent and roll it to the front. So it becomes 1/3 ln of x. Now, here there's a combination, because notice I have this exponent and I have addition in here, but first let's roll this to the front. So I get 2 times log of x plus 4. And that's it. Now, here we have somewhere we're going to do a combination, where we might have to do more than one thing to the logarithmic expression. So remember, first things first, let's change any square roots or cube roots to fractional exponents. So I have log base b of x to the 4th, and like is y to the 1/3. So that's step 1. Change any fractional or any square roots or cube roots to fractional exponents. Step 2, now I'm going to use the product rule. So notice the product rule says when you're multiplying, you do what? You add. So you're going to expand this by adding. So it's log base b of x to the 4th plus log base b of y to the 1/3. Then step 3 is you're going to use the power rule. And remember, the power rule basically just says to take the exponents and roll them to the front. So you're going to have 4 log base b of x plus 1/3 log base b of y. And that is your final answer. Now let's take a look at this next one. Well, this one's division, but the same thing applies. Notice that there's a square root there, so let's change this to x to the 1/2 over 25y to the 3rd. Now notice in this one, not only do we have division, but we have multiplication on the bottom, so we're going to have to keep that in mind. So now, I'm going to expand this. First I'm going to use the quotient rule because I'm dividing. So I have log base 5 of x to the 1/2 minus log base 5 of 25y to the 3rd. Now normally I would say okay, you would have to then roll this y to the 3rd, but remember here you're multiplying two things, so you're going to have to expand this even more. So you're going to have to expand using the power rule again. And to make sure that this multiplication goes on the bottom of the fraction, what we're going to do when I expand it is we're going to put parentheses around this. So first, let's rewrite log base 5 x to the 1/2 minus, and now we're going to expand this by addition. And let's put parentheses around it to make sure that this stays together. So it's going to be log base 5 of 25 plus log base 5 of y to the 3rd, like that. Now, remember, we're going to use the power rule. So remember, we take these exponents and we're going to roll them to the front. So 1/2 log 5, or sorry, 1/2 log base 5 of x minus, and then we have log base 5 of 25, and then we have the 3 here that we're going to move to the front there. So log base 5 of y. The last thing we have to ask us when we're doing problems like this is, can any of the logs simplify? For example, are any of the numbers powers of 5? Like 25 here, is that a power of 5? And the answer to that question is yes, it is a power of 5. The 5 is a power of 25. It is 5 squared. Or 25 is a power of 5 is 5 squared, right? So basically, remembering what happens in this situation, remember if the base and the number are the same, they cancel out, and we get 1/2 log base 5 of x minus 2, because that's the exponent that's left over, plus 3 times log base 5 of y. So notice there's a lot of steps to this, but if you take each step individually and you kind of go through the process here, you'll be able to figure that out. Alright, that concludes our lesson for today. Don't forget to answer the questions on the Google Docs that I will send you. I'll send you the link today after school. And if there's any questions about this, please ask during class so I can clarify any questions you might have about the video. All right, thank you.